So this is an introduction to your spherical mirrors. Now, imagine you have three plane mirrors. So this one, first one, second one, and third one, but they're positioned in a different orientation, like that. And then you have three light rays hitting the mirrors. So obviously, these light rays will follow the law of reflection. So this light ray here at the center will be reflected straight back. Okay, because, well, if we are going to draw the normal line, remember, then the incident ray forms a 0 degree with the normal line, so therefore it also gets reflected with a 0 degree. I mean, in terms of the measurement of the angle, so it will be reflected back. However, in this part of the assembly of plane mirrors, the normal line is like this, right? And so this is the angle of incidence, and so the angle of reflection will be the same amount as that, but on the other side. So it will be like this. Okay, so this one's reflected like this one is reflected like this, and on the bottom one, still the same. You have to draw a normal line, right? And then that forms an angle here, angle of incidence. Then it will be reflected back at that same angle on the other side. It will be reflected like this. Okay, so something interesting happens here, because if you have this form, assembly of plane mirrors, it would seem that all of the light rays would meet at this point. See, this light ray is reflected like that, this light ray reflected like this, and this light ray gets reflected like that. So after the reflection, they meet at a certain point. Okay? Now, imagine being able to make plane mirrors such that they form an arc. Okay? Very small plane mirrors such that they form an arc. Like this. So, for the same reasons that the light rays here meet at the same point, then we can imagine that this one also does that same thing, which is this one gets reflected straight, this one gets reflected like that, this one gets reflected like this, and so they meet at a certain point after reflection. And I want you to realize that that is not because the light rays are not following the law of reflection. Individual light rays follow the law of reflection, but because the surface's angle are changing, the effect is, when you look at the general trend of the reflected angles, they seem to meet at a certain point, right? Now that certain point we call a focus, right? Or the focal point, because they concentrate at one point, so we call that the focus or the focal point. Now, is it possible to make a mirror like this? Yes, this is one type of mirror. So aside from having a plane mirror, which is just a plain, straight, smooth surface, you could have a surface that is curved like this, or on the opposite side, right? So aside from plane mirrors, you can also have two other types of mirrors which have a different shape. And in fact, if I have a spoon, I could demonstrate that this spoon can actually act like a mirror. So if I place it closer to the camera, you can actually see a reflection of my finger, right? So this side is also a mirror, right? It's not plane because it's not straight, but it's a mirror, a type of mirror. Now on the other side of the spoon, still the same. It creates an image, so it's still a mirror, right? So those two shapes form the curved mirrors, and usually this type we call it a convex mirror. And this one, oh sorry, I switched the two. We call this a concave mirror, and this one is a convex mirror. So when the reflecting side forms a cave, right, a depression, we call that a concave mirror. But when the reflecting side is bulging towards you, right, we call that a convex mirror. So all in all, there are two types of curved mirrors. We have the concave mirror, which is shaped like this. So all the light rays are going to hit that side, and then the light rays are going to be reflected in such a way that they meet at a specific point, right? And then you have a convex mirror. And the convex mirror is quite different because, you know, if a light ray hits here, it gets reflected back. But if a light ray hits here, instead of the light ray being reflected and then going down, right, slanting downwards, this one will slant up, and this one also like that. So this is what we call a convex lens. Now to get a sense of how the two are connected, all you got to do is you imagine, you extend this reflected ray, so incident ray, reflected ray, extend that, and also this one, extend that, and then extend this, and still they meet at a certain point. So if this one has a focus, this one also has a focus. So both mirrors have foci, right? But the difference is this one is what we call a real focus, because you can really see that after reflection the light rays meet at a particular point. But this one, we call this a virtual focus, because after reflection the light rays are actually scattered outwards, right? And they don't meet. In fact, this one goes this way, this one goes that way, this one goes that way, and they will their distances will be getting greater and greater away from each other, right? But if you extend them, if you imagine that you're extending them inwards on the other side of the mirror, they would actually meet. But they don't really meet in the real sense, I mean in the real world. It's just that when you extend them, you would find a point where those rays would meet. And so we call that point only a virtual focus, not a real one. So concave and convex mirrors. A concave mirror is when the reflecting side has a depression, a cave in it, right? And its action is to reflect the light rays such that they meet at a real focus. A convex mirror, such as this one, the reflecting side is the side that is bulging towards you, right? And its action is not to focus the light ray in one direction, in one point, such as the concave, but actually scatters the light rays after reflection. But you can actually take the scattered light rays, extend them to the other side of the mirror, and you can find yourself a virtual focus. So, concave and convex. A concave mirror forms a real focus. A convex mirror forms a virtual focus.